Welcome to the Animated Science Chemistry for Beginners. Today we're talking about the periodic table of elements and the Bohr model of the atom. So what is an element? An element is a substance that cannot be broken down into other substances by normal chemical means. So what this means is that the elements are pure substances. They cannot be changed into anything else unless you're talking about radiation, which is something completely different. So elements are basically pure substances. The atom, in contrast to that, is the smallest of unit that retains the property of a specific element that we're talking about. So it is the smallest amount of an element that will still have the same properties of that element. Pretty important distinction to know the difference between an element and an atom. So the atom has been visualized by many different models throughout history as we learn more about them. Two of them have officially stuck with us, with one of them being the most scientifically accurate. So those two are the Bohr model of the atom and the charge cloud model of the atom. Today we're going to be looking at the elements in the Bohr model of the atom. It's a little bit simpler, and it's good to get the main principles of the subatomic particles that make up the atom. And then in a future video, we'll take a look at the charge cloud model, which is also known as the quantum model of the atom. So the first element that we're going to be looking at is hydrogen. And so hydrogen is made up of two particles, the proton and the electron. So the proton is going to occupy a region called the nucleus, and it is positively charged. However, the electron is going to be negatively charged, and it is going to orbit the nucleus in a defined region called an electron shell. And so this electron is going to stay in this region according to the Bohr model of the atom. So one thing to note that this model is not drawn to scale. In actuality, the electron is about 2,000 times smaller than the proton, which usually isn't reflected by the models and images. So the radius of this orbit here is also not drawn to scale, because if this proton here was represented by a golf ball in a real hydrogen atom, this electron could be as far as a mile away from the proton. So it's generally empty space between the electrons and the protons in these elements. And so that's one thing that we have to take note of when we're looking at models, because models will only do so much to explain what we're looking at. So the atomic symbol for hydrogen is the capital letter H. With the atomic symbol, we usually have two numbers that are associated with it, the atomic number and the mass number. So the atomic number is the number of protons, and it defines the element. So all of the elements are going to have a different number of protons. The mass number is the general mass of the element in atomic mass units, or Daltons, and that is going to describe the nucleus, because the electron is so small it's usually not going to make any difference on the mass number. So hydrogen has a mass number of 1 because it only has one proton. And if we move over here to helium, now helium we have some differences, but the first thing I want you to look at is that helium has a mass number of 4. Okay? That's because its atomic number is 2, it's got 2 protons, and it has a mass number of 4. So where did this extra mass come from? The extra mass is coming from another particle that hydrogen does not have, is neutrons. So neutrons are neutral. So going back, protons are positively charged, electrons are negatively charged, and the neutrons are going to have no charge at all. They are going to be neutral. However, they do have about the same mass as a proton, so they are going to contribute to the mass of the atom. So generally, to get the mass number, we add the number of protons with the number of neutrons to get our mass number. So another thing that we notice is that helium has 2 electrons as well, and those 2 electrons are there to balance out the 2 protons. So generally, in the ground state of an element, if this element is not bonded to anything and we're only looking at one single atom, okay, that's a very important note. If we're only looking at one single atom of a specific element, it will always have the same number of electrons as it does protons. Now, when we start bonding these elements with itself and with other elements, we're going to have changing number of electrons, okay? So in their ground state, not bonded to any other element or not bonded to itself, the electrons are going to be the same number as the protons, okay? So thanks for checking out the intro to chemistry. Next time, we're going to continue our discussion, and we're also going to talk about valence shell electrons and the rest of the periodic table. So we'll see you there. Thanks, guys. If you learned something, please give me a like and subscribe. Thanks, guys. We'll see you in the next video.